When we multiply, we look at multiplication as groups of things. So this number line, when we did it on the number line, we can think of grouping or regrouping, but we can also use the model of multiplication as area. So when we multiply, we're basically taking a length times a width, and the product or the answer to the multiplication is the area inside. So here I have a number line going to the right, a number line going vertically, and if I take this length of 1 along the horizontal and length of 1 along the vertical, this shaded area represents one whole part. So what does a multiplication of whole number with a fraction look like? Well, I have 3 times 1/4, and if I want to use the area model, I'm looking for the area that I get when I multiply length of 3 with the length of 1/4. So looking at my area here, my length goes along here to a length of 3. So this edge here represents my length. Then I would go, instead of one whole, I'm going to go 1/4 along that number line. And then the area that I've shaded in green represents the solution to 1/4, or 3 times 1/4. I'm just going to add this up. So this one shaded area, so I'm just going to shade this lightly in blue here. So this 1 by 1, just remember that that represents one whole, and I have 3 1/4 pieces, so I have 3/4 of a whole. So if I can put them back into this one whole, and I can see that I have 3 out of 4 pieces. So 3 times 1/4 represents 3/4. Okay, so that's my area or my product. So if I'm going to multiply 2 times 3/4, well, I'm going to have a length of 2. I'm going to divide up my horizontal, my vertical, into 4 equal parts. Okay, and my 3/4 ends up here. So then the length times the width, here's my length and width. Just going to do that in bold here. I'll use a little bit thicker pen. Okay, so there's my length times width, and the area that I end up with is a shaded area in the middle. And each one of these sections represents 1/4 piece. So when I do 2 times 3/4, I end up with 1, 2, 3, 4, 5, 6 1/4 pieces, which can simplify to 1.5. I'm just going to leave it like that because I can see the number of pieces in the ratio 6:4. And if we look at both of these problems, we can, if we think of our times on top, divide on bottom, that's what we get. We have times 3 times 1 on top, divide 4 on bottom. Here we have times 2 times 3 on top. We get 6, and on the bottom we get divide by 4. So our times on top, divide on bottom model works for this one as well.